All right, good morning, pre-calculus. Today in class, if you weren't here, or maybe we're doing it flipped this year, I don't know. But today we are doing section 1.4. So we're talking about sequences and series, which becomes really important as we progress further into pre-calculus and proceed into calculus. So let's actually talk about what a sequence is, specifically an infinite sequence. So an infinite sequence is a function, so a function like you've seen, a linear, quadratic, cubic, whose domain is the set of positive integers. The function values a sub 1, a sub 2, a sub 3, so on and so forth to a sub n. In other words, it starts at not including a sub 0, but at a sub 0 on. Okay, so a sub 1, a sub 2, so it's integers, okay? So in other words, we're finding different x values that we can put in, and those x values are counting numbers or positive integers, 1, 2, 3, 4, 5, 6, all the way up to infinity. So if the domain of the function consists of the first n positive integers only, the sequence is called a finite sequence. So infinite goes up to infinity. Finite sequence, we stop at some point. So if we say we're only going to x equals 15, that would be a sub 15, which is the 15th term. Okay, so let's take a look at some examples of some sequences. So a sub n equals 3n minus 2. This right here should look really familiar to you. It should look the same as y equals mx plus b, right? The equation of a line. Remember, I said that these are functions, right? We're just finding different values for these functions. So here we want to find the first 4 terms. So we're going to start at a sub 1. So a sub 1, all that means is n is our variable here. So in here, we're going to plug in a 1. It's just like our functions. It just looks a little different because it's called a sequence. So a sub 1, 3 times 1 is 3, minus 2 is 1. Okay, our second term would be a sub 2, so 3 times 2 minus 2 is 6, minus 2 is 4. A sub 3, we would do the same thing, and we would get 3 times 3 minus 2, and that equals 7. And then a sub 4 is 3 times 4 minus 2, which would give us 10. Okay, so the first 4 terms, okay, would be 1, 4, 7, and 10. In other words, if our x was 1, our y value would be 1. If our x was 2, our y value would be 4. Okay, so these are just x and y values. So here's another one. This one is not a linear equation. You can see that it's got an exponent up here, but we're going to work it the same way. So a sub 1 equals 3 plus negative 1 to the, instead of n, we're going to plug in a 1 here. Negative 1 to the first power is negative 1, plus 3 is 2. A sub 2, same thing. Instead of an n up here, we're going to plug in a 2, because that's what term we're doing. Okay, so negative 1 squared is positive 1. 3 plus 1 is 4. A sub 3, you guessed it, we're going to plug in a 3 for our n, and we get 2. And then we could do our 4th term here, and we're going to plug in that, let's see, 3 plus negative 1 to the 4th. A negative 1 to the 4th power is a positive 1, so that gives us a positive 4 as our answer. Okay. All right, so the next one says find the first 5 terms of this sequence. I want you guys to pause this and try to do that. Okay, and then I will show you guys the answers, and we can see if you guys got them right. Okay, so hopefully you guys have found all of these. A sub 1 equals negative 1 to the first power over 2 times 1 minus 1, which is going to give us negative 1 over 1, which is just negative 1. Okay, a sub 2, negative 1 to the second power, or squared, and 2 times 2 minus 1. And that's going to be positive 1 over 3. Okay, and if we continue plugging those in for, sorry, not 1, if we continue plugging those in, a sub 3, we would get negative 1 over 5. A sub 4, we would get 1 over 7, positive 1 over 7. And a sub 5, we would get negative 1 over 9. Okay. You just have to plug the n values in. So the next one says, write an expression for the apparent nth term, a sub n of each sequence. So if we look, this is a sub 1, this is a sub 2, a sub 3, a sub 4. So if we plug 1 into some equation, we're going to get 1. If we plug 2 into some equation, we're going to get 3. Okay, and so on and so forth. But we got to figure out what that equation is. Well, the first thing I'm going to look at is I'm going to look at our differences. So to get from 1 to 3, I have to add 2. To get from 3 to 5, I have to add 2. And to get from 5 to 7, I have to add 2. So because these are first differences, okay, so from these terms, I was able to add 2 each time. That means this is linear. So we know it's going to be in the form y equals mx plus b, okay? But since we're talking about sequences, we're always going to use some sort of a sub n instead of y. And we're going to have something to do with an n in there. So the first thing I'm going to do is see if just n works. Well, if I plug 1 in, I get 1. That works. If I plug 2 in, I get 2. Well, that doesn't work. So then I would try maybe an n plus 1. Okay. So 1 plus 1, I get 2. Nope, that doesn't work. So now maybe an n minus 1. Well, 1 minus 1, I would get 0. So that doesn't work. So then I would start by multiplying the n times something and continuing on from there. So 2 times 1 is 2. Well, that doesn't work. It gives me 2. But how could I get to 1 from there? Well, I could try subtracting a 1. So let's add that in and see if that works. Okay, so we know it works for the first term. Let's see about the second term. 2 times 2 is 4. Minus 1 is 3. That works. 2 times 3 is 6. Minus 1 is 5. That works. It seems to work. So that would be my equation. Okay, so a sub n equals 2n minus 1. Okay, that would be my expression for the nth term of this sequence. Now let's go ahead and look at the next one. So same thing, this is a sub 1, a sub 2, a sub 3, a sub 4. Okay, but here I want to find my differences. So that one's going to be add 3, that one's going to be add 5, that one's going to be add 7. So we know now that this is not a linear function. Okay, so let's see what our second differences are. And we talked about these in algebra too, so they're coming back to haunt you. Okay, so first differences, if they were all the same, it was linear. Second differences, if they're all the same, it's quadratic or squared. Third differences would be cubic, so on and so forth, and then you have ratios that you deal with. So from 3 to 5 is 2, from 5 to 7 is 2. So our second differences are the same, which means it's going to be a quadratic, which means our a sub n is going to have to be something to do with an n squared. So now let's take a look. So this is a sub 1. So if I plug 1 in here, 1 squared is 1. That's not going to work. Okay. So let's try adding or subtracting something. So let's try adding 1. So if I do 1 squared, I get 1, plus 1 is 2, so that works. Let's try a sub 2 and see if we get 5. So 2 squared is 4, plus 1 is 5. And if we continue doing that, we can see that it works every single time. So our sequence, or our expression for this sequence, would be n squared plus 1. Okay, so those are some sequences. Now we have recursive. Okay, so a recursive sequence is essentially the same thing. The only difference is now they're going to base the formula, just like we had up here with the n squared plus 1, they're going to base the formula on the first term or the first terms. Okay, so they're going to have to give you more information. So you see here in this Fibonacci sequence, which is a recursive formula, and you'll be dealing a lot with that as you progress in math, the Fibonacci sequence. You can see that they give us a sub 0 and a sub 1. they have to give us that information because the formula here, once we start plugging stuff in, is going to refer back to these numbers. So it says, let's find the first 6 terms. So let's go on ahead and do a couple of these. So we've already got the first term and the second term. So let's find the third term, which is a sub 2. Okay? So I'm just going to plug it in. So I have a for the k minus 2, a sub k minus 2. So a sub k, well, in this case, my k is my 2. So that's going to be 2 minus 2 plus a sub k minus 1. So a. Okay, so now we have, sorry, my phone rang, I had to answer it. So we have a sub k minus 1. So my k is 2, so that's going to be a sub 2 minus 1. Okay, so now let's simplify these. 2 minus 2 is going to give me a sub 0, and 2 minus 1 is going to give me a sub 1. So you see, I have to have some values here for those, otherwise I can't solve this. Okay, so I know now that my a sub 0 is 1. I know that my a sub 1 is 1. So I know my final answer then is going to be 2. Okay, so now let's look at our fourth term, which is actually a sub 3. Okay, so for a sub 3, I'm going to do the same thing. So I have my a, and this is my k value. So k is 3 minus 2 plus a, my k value, which is 3 minus 1, equals a sub 1 plus a sub 2. So I had to have this one that I just found in order to find this one. So you see how they rely on each other. So a sub 1 is 1, a sub 2 is 2, so 3 is my answer. So now let's go ahead and do a sub 4. Okay, so a sub 4 minus 2 plus a sub 4 minus 1. 4 minus 2 is a sub 2 plus a sub 3. So I had to have those previous two. So a sub 2 is 2 and a sub 3 is 3. So I get 5. Then I've run out of room up here, so I'm going to do this last one up here. So a sub 5, which is my 6th term. This was my 4th. This was my 5th. Okay, so this one's my 6th. So a sub 5 is a sub 5 minus 2 plus a sub 5 minus 1, which is a sub 3 plus a sub 4. A sub 3 is 3. A sub 4 is 5. So that's going to be 8. So it's really not too bad. It's just that you have to find the previous ones before you can continue on. Okay, so going ahead and try this one. It's another recursive formula. You can see it gives you a sub 1, and then it gives you a formula here to plug stuff in. Okay, so it wants you to find the second, third, and fourth term. So the second term in this case would be a sub 2. This would be a sub 3 and a sub 4. So go ahead and pause this, find those, and then we'll see if you guys get the same thing as I got. Right, so hopefully, once again, hopefully you paused this and worked it. So a sub 2, so I'm just going to plug it in here, is going to be a sub n minus 1, so 2 minus 1 plus 7. Well, a sub 2 minus 1 is just a sub 1, which we know is negative 2. So that's going to be negative 2 plus 7, gives me an answer of 5. A sub 3 is going to be a sub 3 minus 1, which is just a sub 2 plus 7. Well, my a sub 2 was 5 plus 7, and that gives me 12. Okay. A sub 4, a sub 4 minus 1, following the formula, plus 7. Well, this is a sub 3, so that's going to be 12 plus 7, which equals 19. Okay, so let's take a look now at summation notation. So we're still dealing with sequences. The only difference is now we're, yep, you guessed it, summing all of our terms. So if we find a sub 1, a sub 2, a sub 3, so on and so forth, we're going to add them all together. Okay, so this little symbol right here is called sigma. Okay. What happens is you have this I, which is called the index of summation. Okay, so I is your index of summation. Essentially, it's going to be some sort of formula, okay, or a function or an expression that's going to be here, okay? And then you have n, which is your upper limit, so that's right here. So that is the last term we're going to find. So whether it's a sub 15, a sub 4, whatever, it's our last term. And then the 1, or the number at the bottom, is our lower limit. Okay? So it's going to be the first term that we find. Okay? So when you add a finite number of terms in a sequence, you're actually finding what's called a partial sum, because you're not adding every single term that could exist, okay? Because there could be an infinite number of terms, okay? So you're finding a partial sum of a series. When the sum of a series is written like this, with this sigma symbol, it's actually called sigma notation. So you need to know that this is actually a partial sum. Let's see, what do we got next down here? Okay, so let's take a look at some properties of sums. We're going to get into this in more detail when we actually get to series and sequences in Precalc, but for now, I just want to kind of introduce you to this. I want to introduce you to the concept that when you have this sigma notation, you can actually use distributive property, associative property, and commutative property and change things around. So here, if I'm looking for the partial sum of a constant, which is just a number, I'm just going to multiply that number times whatever my n is. Okay, so on this one, you can see that for sigma notation, so we're finding the sum of a constant times some expression. Well, I can actually pull this constant out, and after I found the sum, I can just multiply that sum times the constant. Okay, so same thing here. I'm finding the sum of two expressions added together. It's the same thing as finding the sum of one expression and then adding it to the sum of another. Okay, so, and once again, we will get deeper into this when we actually get to sequences and summation in a later chapter, but for now, I wanted you to at least see this. So a couple of things, if you consider the sequence, a sub 1, a sub 2, a sub 3, okay, so just pretend these are numbers, 1, 3, 5, 7, whatever. The sum of all the terms is called an infinite series, and it's denoted by the sigma notation starting at 1, ending at infinity, okay? So an infinite series, you go up and up and up forever, okay? But if we're only finding the sum of a certain number of those terms, then it's called the partial sum. And you can see that it's denoted by the n at the top. So that means that's the term that we stop at when we're adding them. So let's take a look at how that works. So here, we want to find, for the series, 3 over 10i from I equals 1 to infinity. We want to find the third partial sum. In other words, for I equals 1 to 3, the third term of this function. Okay, so what we're going to do is we're going to take this function here, and we're just going to find a sub 1. So we're going to plug a 1 in there, plus a sub 2, so we're going to plug a 2 in there, plus a sub 3, so we're going to plug a 3 in there. Okay, so that's going to give us, so this becomes 3 over 10, this becomes 3 over 100, this becomes 3 over 1,000, which translates to 0.3 plus 0.03 plus, oh, I'm way off the page here, 0.003, right? So tenths, hundredths, thousandths, okay? So when I add all these together, I'm going to come up with 0.333 repeating, okay? But since I'm actually stopping at the third sum, we can say that it's just 0.333. Okay, that's it. We're stopping there. However, If we go on forever and ever and ever, and we find the sum from I equals 1 to infinity of 3 over 10 to the I, okay, we know that it actually becomes 0.3333333 forever, because every time you add another 0 down here, it's going to expand this out more. Well, we know that that is actually 1/3. So that would be the difference between the two of those. One of them stops and one of them goes on forever. Okay, so you will be finding some partial sums and some infinite sums. Okay, but let's actually look at an arithmetic sequence. So a sequence is arithmetic if the difference between consecutive terms are the same. In other words, if here I have 3, 5, 7, okay, the difference there is 2, the difference there is 2. So 5 minus 3 is 2, 7 minus 5 is 2, and so on and so forth. Okay, so our first difference is 2. Okay, so our arithmetic sequence is actually a linear equation, and our m, or our slope, is going to be that difference. Okay, so that is going to be our slope. Okay, so let's take a look here and see what our slope is. So here, what is the d? Okay, so let's go on ahead and see if we can figure this out. Well, we can look here and see that our slope is 4, so hopefully you've all said 4. But if you didn't see that, let's go on ahead and find A1 and A2 and see what our difference is. So 4 times 1 plus 3 is 7. 4 times 2 plus 3 is 11. 11 take away 7 is 4. So our difference is 4. Okay, so same thing here. So you can either look and see what your slope is. So our slope here would be -7. So we're going to say that our difference is -7, but let's go on ahead and double check that. Okay, a sub 1 equals 5 minus 7 times 1. And that's going to be, let's see, -2. A sub 2 equals 5 minus 7 times 2, which is going to be -14 plus 5, which is -9. And if I do -9 minus -2, because remember, it's always that second term minus that first term, okay, I get -7. Okay, this one right here, what do you think it's going to be? It's going to be 1/4. So you can see it's written a little bit different, but remember, we also have this formula for a line, y minus y1 equals m times x minus x1. Okay, so same thing, but here our y1 is 0. So in other words, this line, okay, has a y1 of 0 wherever our x1 is. Okay. All right, so this is just the equation of a line. So we know already that our slope should be 1/4. So that would be our d, okay, or our difference, okay. So our common difference is 1/4. But if we plug in a couple of values, oh, that was supposed to be an a, not a d. So if we plug in a couple of values and find the first couple of terms, we would say 1/4 times 1 plus 3, which is 1/4 times 4, which gives us 4/4, or 1. I'm just going to leave it as 4/4 so that you guys can see. So if I plug in a 2 here, I get 1/4 times 1 plus 3, which gives me 1/4 times 5. Oh, 2 plus 3 gives me 5/4. And you can see to get from 4/4 to 5/4, I have to add a 4th. Okay, so common differences. You're going to have to be able to figure that out. So this next one says, is 1, 4, 9, 16 an arithmetic sequence? Well, let's see. To get to 1, from 1 to 4, it's 3. From 4 to 9 is 5. From 9 to 16, it's going to be 7. Okay, so no, this is not an arithmetic sequence because it does not have the same common difference. Okay. All right, so now these next 3 parts all relate to each other. So the nth term of an arithmetic sequence has the form a sub n equals dn plus c, right? So mx plus b, Okay, same thing. It's a linear equation where D is the common difference between consecutive terms. Okay, so it's going to be our A sub 1 minus our D. Okay, that's our C. Okay, it's our y-intercept. Another form, sorry, is just like what I did up here. It's our equation of a line in point slope form. Okay, so our A sub n equals A sub 1 plus n minus 1 times D. Or we could rewrite it as A sub n minus A sub 1 equals D times n minus 1. Okay, same thing. Okay, so n is our x value and the A sub 1 is our y value. This is going to be important. Remember this, memorize it, put stars on it, highlight it, okay, write it on your bathroom mirror. Okay, so let's take a look at how we're actually going to use this. Let's see if I can switch pages here. My fingers are kind of sticking together. Okay. All right, so now this one says, find the formula for the nth term of the arithmetic sequence whose common difference D is 3 and whose first term is 2. So A sub 1 is 2. We're just going to plug it into our formula here. So A sub n equals A sub 1, which is 2, plus n minus 1 times my D, my common difference. Okay, so now I'm going to be able to just distribute this 3. So I get A sub n equals 2 plus, I'm going to distribute this 3 to both of these, 3n minus 3, and now I have some like terms to combine. So A sub n equals 3n minus 1. Okay, so that is my formula for this particular arithmetic sequence. Okay, sorry, I have my kids in here, so every now and again you might hear them, even though they're supposed to be quiet. All right. So let's take a look at this next one. It says the fourth term of an arithmetic sequence is 20. So let's look at this as actually having a coordinate. So my fourth term, my n, is 4, okay? And my y value that I get out when I plug that in is 20. And the 13th term is 65. So it's kind of like points, x, y coordinates. Okay, so now we're going to have to write the first several numbers of this sequence. But first we have to actually find the formula. Before we can find the formula, we have to find the common difference. Well, remember I said the common difference is actually the slope. So how do we find slope? y2 minus y1 over x2 minus x1. So we're going to get 45 over 9, and our common difference then is going to be 5. So now we can go on ahead and plug this in. A sub n, okay, equals A sub 1, which is 20, plus our slope, 5, times n minus 1. I'm going to distribute, and I get 20 plus 5n minus, oh, I lied to you guys. So why is this not 1? Okay, because it's really the fourth term we're using, so that should be minus 4. Okay, so that should be 20 plus 5n minus 20. Okay, those are going to cancel. So our A sub n is just going to be 5n. Okay, so our arithmetic sequence is 5n. It says find the first several numbers of the sequence. So A sub 1 I could plug in and I get 5, right? Because 5 times 1 is 5. A sub 2, 5 times n would be 2 is 10. Okay, A sub 3 would be 15. A sub 4, well, we already know that because we were given it. But it works out, it would be 20, and so on and so forth. Okay. So once we know what an arithmetic sequence is and we know the sequence, then we can actually find a sum of the finite sequence. Okay. So in other words, we can find the sum of all of the terms added up from the first term here to the last term. Okay. Well, if I was going to do that by calculator, I would have to take every single one of these and add them up in my calculator. Well, for here, it wouldn't be too bad. I would just do 1 plus 3 plus 5 plus 7, right? And so on and so forth. But sometimes, like this next problem, that's going to be all the integers from 1 to 100. So I would have to add 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100. And there's a lot of chances I would make a mistake. So we're going to use this formula here, which you guys are going to need to memorize. Once again, write it on your mirror, make some note cards, hint, hint, okay, for the stuff that you need to memorize. Okay, so we're going to go ahead and plug this in. So the sum would be S sub n, okay? N is the number of terms. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms divided by 2. Our first term is 1, and our last term is 19. Okay, so now we're going to have 10 divided by 2, which is 5, times 20. So if we add all those up, we get 100. Okay, so this next one here, same thing, from 1 to 100. We have 100 terms divided by 2. Our first term is 1. Our last term is 100. So that's going to be 50. 100 divided by 2 is 50 times 101. So the sum, if we add all of those up, is 5,050. Okay, we have a couple more here dealing with partial sums, okay, and sums. So the sum of the first n terms of the sequence is called the nth partial term, or partial sum. So here we're going to find the 150th partial sum. We're going to do it the exact same way using the exact same formula, okay? But our n value is going to be 150 in this case. So S sub n is going to be 150 divided by 2 times 5 plus, we don't know what that last number is. We're going to have to figure that out. And in order to figure that out, we need to find the arithmetic sequence first. So that's this other formula, a sub n equals a sub 1 plus n minus 1 times that common difference. Okay, so a sub n equals, our first term is 5, plus, well, we're going to wind up finding the 150th term. So if we want, we could go on ahead and plug 150 in there and work it out. Or we could just find the formula first and then work it out. So n minus 1 times d, our common difference to get from 5 to 16 is 11. 16 to 27 is 11. Our common difference is 11. So if I go on ahead and distribute and solve this, I get a sub n equals, let's see, 5 plus 11n minus 11. So that's going to be 11n minus 6. Okay, so now I have to find a sub 150. And when I plug 150 in here, I'm going to get 1,644. So that's my final answer here. Okay. Now I can finish plugging it into this. And when I plug it in, I get 123,675. And I know that you guys don't know the use for these yet, but I promise these are going to be used quite frequently in calculus. Okay, so you need to really make sure that you understand these sums and that you remember them, and we will touch on them again later in the class. Okay, so here's another problem using them. So an auditorium has 20 rows of seats. There are 20 seats in the first row, 21 in the second, 22 in the third, and so on for 20 rows. Okay, so you need to notice here that this is 20 and this is 40. So this row right here isn't exactly our A1, okay? If you start with 20 and then you count up here and you miscount, you're going to wind up with 39 there, okay? But there's really going to be 40 because you have to include both of those rows, okay? So let's go on ahead and find our sum. So S sub n, okay, equals, how many rows are there? 20. Okay, so 20 divided by 2. Our first term is 20, and our last term is 40. In this case, we didn't have to find an arithmetic sequence because we're given the first and the last terms. So if we solve this, we get 600. So we can find out that there are 600 seats in this auditorium. Okay, if it's 600 people. Okay, another good question here. It's a word problem. It says a small business sells 20,000 worth of sports memorabilia during its first year. So its A sub 1 is 20,000. It says the owner of the business has set the goal of increasing annual sales by 15,000 each year. That's going to be our D. Okay, so 15,000 is going to be what we're going to increase by each year. for 19 years. So we're going to have a total of 20 years. Okay, so our N, when we find our sum, is going to be 20. So the sum of N, okay, is going to be 20. So that's going to be 20 over 2 times, okay, our initial amount was that 20,000, plus we need to find what the final amount is after we've gone 20 years. Okay, so now we need to find our A sub N. So that's going to be 20,000, A sub 1 plus N minus 1 times that common difference. And we can plug that 20 in here, or like I said before, we could actually solve for it and then plug it in. And we're going to get an A sub 20, that's 20 years is what we're looking for, of 305,000. Okay, so we're just going to plug that last number right in there. Okay, so that's the amount of cells he plans to do in his after 20 years of being in business. Okay, so our sum, then our total cells over that entire course of 20 years is going to be 20 divided by 2, which is 10, times 325,000. Well, times 10, you can just add a 0. So he expects over the course of 20 years to have cells of $3,250,000. Okay. So you guys go ahead and do whatever assignment you have for tonight, and I will see you next time.